So I'm going to use nano here and simply create a script called python1.py. You probably want to use a lot better naming convention than that, but that's okay for what we're doing here in this demonstration. Now, rather than trying to type this manually, I'm going to paste the script in so that I don't make lots of mistakes. The first thing we're going to do is import Pyshark. This is a variable. We're going to use Pyshark to live capture off our interface Ethernet 0. I'll save that script. ifconfig shows us that this is the network interface card. We can see that in GNS3 anyway, but this shows us in Linux that that's our Ethernet card. I'll edit that script again. So we're going to capture traffic off Ethernet 0. We've got a loop here saying for packet in capture, we're going to continuously sniff, but we're going to capture 50 packets. So this will start Pyshark and start capturing packets off the wire, but only 50 packets. Now I don't actually need to write to a file. I'll remove that. What we're going to do here is some exception handling. We're going to try and print the source IP address and destination IP address. But some traffic types like spanning tree don't have a source destination IP address. So they'll give us an error. So I've got a try statement. And if we receive a spanning tree packet, it's simply going to say continue running the loop. So this pass basically is just a null statement to put something there so that the script can continue. I'm then going to print at the end, and I'm going to exit out of the script. That sometimes solves the issue that I had with Pyshark. In other words, the error that it was displaying. So let's run that. Python3 python1.py. What this should hopefully do is start Pyshark and start printing out the source and destination IP addresses. So as we can see here, a source IP address sent traffic to this IP address. That's EIGRP. This source IP address sent traffic to this IP address. That's OSPF. So on my router, show IP interface brief. This shows us the IP address of the router. Show IP protocols shows us the routing protocols enabled on this router. So just scrolling up, this IP address is sending updates. As we can see over there, there's a source IP address to multicast IP addresses. Firstly, the one for EIGRP. EIGRP uses 10. There's EIGRP's multicast address. OSPF is sending updates. Here's OSPF's multicast IP address. So we can see in the updates there that the router is sending EIGRP updates as well as OSPF updates into the network. And Wireshark, or in this case Pyshark, has captured those packets. I started Pyshark via a Python script, and then I did something. I got it to just print out the source and destination IP addresses as an example. Now this once again is that exception error. I'm going to ignore it for the moment. There's the end of our script. What I'll do now is run that script again, but what I'll do here is I'll ping 192.168.122.255. So ping a broadcast address. Notice it's displayed as that 255, 255, 255, 255. So that broadcast ping has been received by the Wireshark application. Notice there's the destination multicast address 239 1.1.1. Do that again. There's the multicast once again being captured by Pyshark. Let's do 123. There you go. So this is a very simple script. We're not doing that much here. We are essentially just printing source and destination IP address. What we could do is do something else. So let's print out EIGRP autonomous system number. And I should preface that by saying EIGRP AS equals that. Save the script. So Python 3 python1.py. Notice we can see in the output that the EIGRP autonomous system number is 100. So again, I'm capturing packets in real time off this network. This Ubuntu host is capturing packets of Ethernet 0, and I'll just stop that script at this point. I can see what the source IP address is, what the destination IP address is, and what the EIGRP autonomous system number is. Now this is again a very, very basic script. You could use if statements here. You could do much more complex things. So if it's EIGRP, then print the autonomous system number. If it's spanning tree, then do something else. All those options exist with Pyshark. And I mean, you can leverage the power of Python here to do all kinds of fancy things. The moral of the story is I've used Python to start Pyshark to capture packets off the wire. Then I'm looking at those packets and then doing something with the information that's captured. This is a very simple example showing source and destination IP addresses and EIGRP autonomous system numbers, but you could do something much more complex.